So this talk is actually, this can be fun, this can be a total disaster, and it does depend on you guys. This originated in me doing a talk for a client because they wanted to learn about 12c, and I put together the slides and I talked about a lot of stuff. And there are a couple of features in there that I'm really familiar with and I'm really confident talking about. Some not so much. I'll still try to talk about them. But it also means if you have questions or comments or just are much smarter than me, just yell at me and let me know. So again, me introducing me, introducing us. So at Portrix, the day 12c went live, we ordered pizza, stayed in late, and installed that whole install first geek thing. So we've been testing ever since it came out. We didn't do the beta program. One of the reasons most of the time I feel like I don't want to do beta programs because I don't feel like I want to be Oracle's unpaid beta tester or developer, if you will. I'm slowly changing my mind here because my impression is that whatever product Oracle throws at you, you're still being their beta tester if you're using the first release. With the difference being, and this is from people that I've talked to, is people that have been on the beta program said that whenever they find something and they get the feedback back to development, they get the feedback straight back to development, and development would actually fix these things. Whereas once a product has been properly launched by Oracle, you have to raise a service request and prove that something is actually a bug, and then wait for half a year to fix this. Good example is I chose not to be a beta tester for the most recent Oracle VM product, version 3.3. I waited for it to come out, installed it the week it came out, found a couple of bugs, including kernel bugs where I was able to actually give them patches and point them to the exact source code line where the bug was, and it still took me 5 weeks to convince the analyst that this was actually a bug. And then in the end they told me, yeah, it is a bug and your fix works, but we're not putting the product until the next release, which is 6 months from now. So that's why I may change my mind and actually participate in beta programs in the future. I told you earlier, we are an ISV, and we just certified, well, basically we just said our application is supported on 12c. At the point where I was first talking about this, DAF vendor software as a service production environments are all running on 12c. We have a couple of clients that are still wanting to run 11g, but most of our databases now are actually 12c, which is kind of cool. Really enjoying that. So this is just to show you. This is I copied this from the Oracle documentation. This is a simplified picture of how 11g works, and then my point is 12c is just the same. There's nothing much added to it. And again, this is just a screenshot from the documentation. Really, there isn't. I mean, this one is really just very much simplified. This one just looks so complicated, but there really isn't that much new stuff. The way this talk works, it's a bit broken down in parts of some things that aren't really new because they have been there in 11g. I also talk about some things that they deprecated. I'll talk about very new, and then I'll talk about, hopefully don't talk about too much about Pluggable and in-memory, because these are the very big, very new features. A couple of things that aren't there anymore, and one of them is Oracle Restart. Oracle Restart is a product you use to well, start up your Oracle instance and or your clusterware stack in a single instance environment, and it's just very confusing. So in the release notes of 12c, they tell you 12c is deprecated, but they don't say anything else. It's still there, it's still supported. What they wanted to say is, in the future version of Oracle, they may get rid of Oracle Restart, but not until they actually have provided a proper replacement for it, if that makes any sense. So don't freak out about that. Oracle Streams is being deprecated, and that's a problem if you're using advanced replication for that. Oracle wants you to use Golden Gate. There are other alternatives, but if you are using advanced replication, that could be a showstopper for 12c. Raw storage, I don't know anybody who's still using raw storage or enjoys using raw storage. That's being deprecated for ASM. And stored outlines are being deprecated for baseline, so there are replacements for those. Not really new is, so this is one that I just talked about, SQL Plan Management. The other feature that I like talking about is flashback data archives. And just in short, there's two things that it does for you. So flashback data archives enables, has a background, there are slides about it. Cool. So it definitely basically allows you to enable an under retention or retention for historic data on a per table basis. Since Oracle version 10, you had the ability to do a version query as in select something from a table as of yesterday. And the way Oracle did this was it has to keep this data in the undo anyway for read consistency for as long as you have active transactions going on. And this just doesn't hurt to keep the undo around for longer and then enable you to actually query it. What's new with this FlashBay data archives is it allows you to specify this on a per table level, whereas the old method was just undo system-wide. You can do this on a per table level. There's a background job that asynchronously mines the undo information and stores the undo information basically for the tables that you are interested in a specific, in another table. And this allows you to do what I call versioning time travel, so you can just roll back your application and say, I want to query my application as if it was yesterday or last week. This is also great for auditing, and one of the use cases, and we talked about this in Perth, because Colin McDonald mentioned this, is another good use case is cases where you have audit tables and audit triggers on your tables. So you may have tables that you want to just record whoever did a change and when. And you could have a trigger or update insert delete that would actually write something like the sys context or the session context of that session to a different trigger, a different audit table. The problem with this is this happens synchronously and takes from your performance of your live system, whereas this just runs in the background and your session just commits as fast as it needs to. Cool feature about 12c is 12c also stores the session context with it. In 11g you could not do that. You could store the username, but with 12c you can also store which machine everything that's in vSAR session that can be stored in a system context. The other cool thing is this FlashBay data archive is free now. So up until 11.203 there was some license that you had to buy for it, and starting in 11.204 and 12c the default is you can use this for free, even in standard edition. You can choose to compress the data archive, so the historic tables, and if you want to do that, then you need to buy the advanced compression option. It's not yet supported in Pluggable, which means we are not using Pluggable. Secret management, talked about this for an hour. Network encryption is nothing really new, but in 12c you can use it for free with Enterprise Edition. So if you want to encrypt the SQLnet traffic between your database and your clients, you don't have to buy the advanced security option, I think it's called. You just do that now in 12c. Another thing, this is really more performance, is direct path reads. And again, this is not something new, it's just something I want to talk about, is in 11g, Oracle introduced these direct path reads. And the good intention here is, if you want to scan a large table and you want to full scan it, there may not be a need to put this stuff in the buffer cache. If you just want to scan a large table, that wouldn't fit in the buffer cache anyway. You can just read it directly without putting the buffers in the buffer cache first and then reading it and then, removing them again from the buffer cache, putting them back in again. That's called direct path read. It works for full table scans, and it's good if it works well. There are two problems with full table scans. One is the wait event for it is still broken in 12c. It's broken in 11g, it's still broken in 12c. And what I mean with broken is direct path reads use asynchronous I/O. And from a user perspective, it does issue I/O, and I am waiting for it. But the way the wait event works, it'll only record the time where it actually reads the I/O, and not the time it actually takes to fetch the stuff from disk. So you will see very little I/O waits, a lot of CPU time, where in fact it is waiting for I/O, it's just asynchronously waiting for I/O. Does that make sense? Wait I/O broken. The other beef I have with this is the decision if a full table scan should go through the buffer cache in a traditional scan or a direct path read is made at runtime. So whenever a query executes, the execution plan will just say full table scan, and then at runtime, based on how big is the table, how many blocks of this table are already in the buffer cache, Oracle will make this decision of doing direct path read or not at runtime, and that just can be very confusing. Yes, Tim?
Rick's going to talk about this as well. Nothing's really confusing is that when you do the direct path read, the size of the reads can be enormous. So when you're looking at the weight events you do get, you can think, oh my God, my storage is performing really badly, but because it's doing a gigantic read. So it's very hard to look at it and say, is this read performing well or not? Because they're very different size reads.
Yeah, that's true. Yeah, and Fritz Hoekland has tons of blogs about this. He has an awesome presentation about this where he uses a kernel debugger to look at the system calls in Linux to simulate this. He did an experiment where he set up a virtual machine and limited the I/O throughput of the virtual machine to 1 I/O per second to show these things. It's a really good presentation. Fritz, there was something else I wanted to say about Fritz. Can't remember what that.
He's the shortest Dutch person you'll ever meet.
Is he? Probably is. So that's direct path reads. Very new, and very new is now divided into different areas. So for people who write SQL, these are the new things in 12c. One is this top-end query. So now you have the syntax where you can say, I only want to fetch the first five rows. This is something that my MySQL and Postgres friends have always made fun of us Oracle folks, as they said, yeah, you can't do this. I think this is a solution to a problem that we have solved 20 years ago. Yes, it is annoying to write subqueries, but all our applications are already doing it. So, to me, this isn't that big of a deal.
What's the big difference between fetching the first 5 rows only and where row number less than 6?
This is more convenient to write.
Because you don't have to do it. It's a proper top-end query. If you do the row num, the ordering is done after the row num, so you don't get the lowest 5 or the highest 5. You have to do an inline view and order it. But actually, if you look at what the optimizer does, it converts this into analytic function in an inline view. So it's just a query rewrite. But it's fucking brilliant.
Yeah. So this is convenient, and under the hood, it's still doing the same thing. And again, this whole talk is just me linking to Tim's articles, and don't go there. The other thing is you can now store 32 kilobytes in the varchar 2 column, and developers say, oh, this is so awesome. And I'm telling you, don't use this. One of the reasons why I don't want you to use this, by default at least, is everything that's larger than 4,000 bytes or characters will be stored externally as a character large object, with all the consequences that come with it. So when developers first hear this, 32 kilobytes, they think it's awesome. I want this for all my character fields. But really, it's just, again, it's a convenient way of doing clubs. But we as DBAs, I mean, I don't want clubs whenever I can avoid them. So don't do this. Yeah, my feeling is stay away from this. Row pattern matching, don't know much about this, but again, there should be a link to, there's not a link to Tim's thing here. This is useful for, if you look at patterns, if you look at, we had, Connor's girlfriend was talking about this stuff, because she actually uses this. She's doing fraud detection for the Western Australian Betting and Wagering Organization, WABA, or something like that. And she looks for weird patterns of behavior. So people who make like 10 bets in one location and then withdraw or cash out the money at a different location, and they look at patterns. So and the ones that Oracle always give in their examples is you look at stock prices and you want to look at the one point where stock price actually is not increasing anymore from one data point to the next, but it's decreasing. This can now easily be done with row pattern matching, but I haven't used this at all so far. Invisible columns is a new feature. So you can now create a table and set a column to invisible. Which basically means if you do a select star from something, this column will not be shown. Same if you do an insert, I think. And I guess this can be practical between deployments. So if your application uses this syntax, select star from something, and your next version of the application needs this extra column, you could add this today as an invisible column, fill it with default values the way you want it to. But unless the application explicitly mentions this column, it will not be shown. So if the application still does a select star from this table, it will only show the visible columns. Does that make sense? Cool. Identity columns is this other thing that other people made fun of me. Because MySQL people said, oh, it's really easy, just say whatever default value to whatever thing. Oracle can do this too now. And again, under the hood, so you just say I have this ID and it's a number generated always as identity. That's the syntax. And under the hood again, it'll create a sequence for you, and it'll just by default fetch values from the sequence and put them in there. And again, I think this is a problem a solution to a problem we solved 10 years ago, 20 years ago, because we didn't used to have auto-increment in our tables, and our application still worked. So I think this is cool to have, but I still don't see people using it.
Does it still work the way sequences do? So if you've got a cache and you shut down and start up, you get a gap in
it is using a sequence under the hood.
Yeah, so it still works that way.
Yeah,
yeah, which you don't get on the SQL Server. Or,
you can just have a default value of a sequence as well now. So if you don't want to do the identity, you can just make the default value a sequence. And it will do. It matches the same thing. I think the important thing for this and the 32K is if you've got projects that are migrating from things like MySQL to this, then 32K is brilliant and this is brilliant. If you're an Oracle shop anyway, these you might want to use them, but like I agree with Bjoern, 32K varchar 2 is a disaster.
Yeah, absolutely.
This is nice, but not essential.
Yeah. The other reason I heard people mention 32K varchar would be for the JSON support that's new now, but where you might want to store.
If using JSON, unless you've got a definite idea of the site, you're going to want to put it in a club anyway, because it's unformatted, so you don't know if it's going to be sort of 30 characters or 3 million characters.
Yeah.
It's dangerous to make an assumption. I would always put it in a club.
Yeah.
It's a database within a database. You should be using a SQL database for that sort of thing. Really.
Unless you're on 12C.
There is a place and time for stuff. Except we've done this once, and we've done something I would say it's a bit crazy. We stored XML in a database, and we had foreign keys from XML nodes or XML values back to relational tables. That was a bit scary, because at some point we get an error message saying feature is documented but not implemented, please contact Oracle support. And then we did contact Oracle support, and 2 years later they came back to us saying, "Hi, we still haven't fixed this, but can we please close this as R?" I'm getting bad feedback from our manager. So for DBA, so I think most of the development features, like Tim said, I mean, they may be good if you're migrating from a database that has these features and you don't want to reinvent the wheel and change your code. But for Oracle shops, or if you have Oracle, I really wouldn't touch my existing Oracle applications, rewrite them to use identity columns just because I can now, because there's really no benefit there. For DBAs, there's some stuff that I find quite cool. One thing that I find really useful is this capture privilege usage thing. And so this may be useful in projects that come up every year or so, where some security auditor is coming, and then the question is, we want to implement this principle of least privileges in our databases. Can you please take away all the privileges that our users don't need? Or the other one where we need to go live tomorrow, just grant DBA to the apps user. We can still fix this later. And then we never do, because it's really, really a big pain in the ass to determine which privileges something actually needs. For two reasons. One is, actually it's just one reason, because Oracle privileges are really, really confusing, at least to me. I really don't understand which roles, privileges, stuff you need. And then once something is out in production, the only way to test this would be to take something, well, to look at this and be really smart, or to take something away from the user and see if anything breaks. In 12C, there's something that unfortunately only comes with the advanced security option, and it's called capture privilege usage, and it does it solve this problem. You enable the capture of this privilege usage information for a session or for a user with a logon trigger, and wait for a while. Wait for it to actually do everything that this application does, and then you can display the privileges that were used and also the ones that were unused. So you let this run, and then you ask, give me everything where HR manager or sales clerk roles were used, and I get this username Jim. He used this HR manager role to access select on the employees table. So you can do this. Or even better, give me the unused privileges where the role name is in there. And it does have the ground path, and I really can't read this right now. So delete employees was not being used from HR manager. So this will give you a clue as to which roles and which privileges are actually removed from a user. I think this is really cool. Other nice feature, temporary undo. This is also important for active data guard. So temporary tables, really cool, really useful for, well, doing temporary stuff. The good thing about temporary tables, they are not being persisted to a table space. So whatever you do in a temporary table is not being written to disk. Unless you actually change stuff in there, and when you change stuff in a temporary table, that generates undo. And undo does go to disk, because there's always an undo table space. And then undo generates redo. So even if though you have a temporary table, once you modify stuff in a temporary table, you do still generate undo and redo. But now there's something called temporary undo, and this gets rid of the undo that's written to disk, and by that also with the redo. This also allows you to use temporary tables in Active Data Guard now. So Active Data Guard in 12c can use temporary tables, because temporary tables are now not writing anything to the database anymore. Did I get that right? I think I did. And this is not Tim's website, it's actually oracle.com. Atrocity. I should probably do that. And this is Richard Foote. He's coming to UKOG next week. Async global index maintenance. So, problem was one of the big advantages of and we talked about this, Tim, last week in the plane. One of the big advantages of partitions are how easy it is to just drop a full partition of data, because you don't generate undo, redo for the thing you drop. But the problem is when you drop a partition, any global index will have to be maintained or rebuilt when you drop the partition. And that will put a lock on the index, by that put a lock on the table, and be a big pain in the ass. Also, the primary key has to be global, and it's also the partition key. So you end up with at least one global index on the table. A workaround that we did was we just dropped the index and then recreated the index afterwards. That helped us. But in 12c you can do the index maintenance asynchronous with the drop. So you can drop a partition and decide you want to leave the global index with entries that are basically pointing to nothing because the partition isn't there anymore. And then you can clean this up later, or just never clean this up, I guess. But you probably should clean this up later. Useful. Online data file move is a really, really small and tiny feature, but people love it. So now when you move a data file, and it doesn't matter, you can move it on the same file system, or even if you move it between file system and ASM, you can do that online. So you no more need to take the database down and put the table space in read-only mode or offline. You can do it online now. And it's really easy, because it's just that syntax. And there's Tim's URL again. And there's the docs. I do read the docs too. PGA aggregate limit is a new instance parameter that has a good intention, I think. Because sizing PGA is always a bit of black magic to me. The problem with PGA sizing is no one knows how much PGA you will actually have. And that's because the PGA is being determined by the number of processors that you have at any point in time and the memory per process. So if you have very few processors, you can afford to give them larger memory. If you plan for many processors, you better plan for making them small. The one thing that you want to make sure is to not start swapping, because if you have a database system and you start swapping, you are generally in hell. And if you set something like the PGA aggregate target, which is an 11G or 10G parameter even, that will try to take care of this by if you are over that limit, it will only give the minimum memory to a server process. In 12c, there's a new parameter called PGA aggregate limit. It defaults to twice the PGA aggregate target, and it's on by default. And what it will do is, once you are over this limit, it'll terminate the SQL that session is running, or that a session is running. And if that doesn't even help, it'll just kill and kick and disconnect sessions until it's under this limit again, which I think is something that can really, really be painful. And it can be painful to diagnose as well. I haven't encountered this yet, but I'm saying this is something that will probably come back and haunt me someday. Or you. Hopefully you. Better you than me. Yeah, so you can disable it, but it's on by default. If this aggregate target is large enough, then chances are you won't really get into this, or it'll only kick in once you actually have started swapping. But if this limit is set too low, weird things can happen, as in random sessions disconnect and you have no idea why. Data pump transform. This is one of the features that I'm not so confident talking about. But there's this new parameter for data pump that allows you to basically specify we want to do stuff in no logging. It'll set your tables to no logging, then import stuff in your tables, and then set them back to logging afterwards. And the workaround before used to be, if you have large data pump imports, disable your archive log mode to not do that. Maybe also manually set your tables to no logging. There's now one command to do this, I think. And again, it's not Tim blogging about this. That's for DBAs. Optimizer stuff, new in 12c. Let's see what we have. There's this new big thing called adaptive plans, which basically comes in two flavors: join methods and parallel distribution methods. So when anybody's talking about adaptive query or adaptive plans, these are the two things that they talk about. Adaptive join method. The way it works is it works only for nested loop and hash joins, but not for what's the third join method? Sort merge join. Doesn't work for those, but it does work for nested loop and hash joins. And the way it works is the optimizer will just calculate both plans. If it has a nested loop join and a hash join, it'll calculate both. It'll start with the one that has the lower cost, but it'll also start a statistics collector with it. And if the statistics or the runtime execution actually fetches more rows than it thinks it estimated, it can switch to the other join method on the fly and still use the results it has fetched so far. After it has done this once, it'll just record this as a resolved adaptive plan, store this in the SQL cache, SQL area, a shared pool, and just use this from then on. So this should only happen on the first execution of a statement. This can happen more than once. So if you have a statement with more than one join, this could happen for every join in the query. Did I get that right? Do I have everything? Yes. This also can be very confusing with SQL file management. This was one of the other things that I have researched, I have talked to Maria, I have forgotten again. I think for this to work with SQL plan baselines, you have to have both plans except. This is really just, I think, this is the way I remember this. This could be completely wrong. I think you need to have both of them accepted first for the optimizer to be able to change between the plans, and then the resolve plan should be stored. I'm not even trying this. There's a picture I stole for adaptive join methods. Adaptive parallel distribution is the other adaptive query optimization thing. The problem here is, traditionally, if you have parallel execution, you divide your workload into chunks before you start them. Then you send off a number of parallel workers, they do their work. And this can work really good or not so good. The problem could be if the chunks you choose, or the chunks your Oracle chooses for you, aren't so well distributed, and some chunks just take longer to execute, then you're basically just waiting for that thread to execute. There's a new distribution method called hybrid hash, which distributes work during runtime. So each parallel worker will get some work assigned, work on it, and then get some more work. So you won't see many idle workers anymore, because all of them should actually finish at the same time, because they all get fed back with work. This is stuff that I really don't understand. Really just trying to fake my way through this. Dynamic stats, dynamic sampling. Let me read the slides first. Yeah, I think this is the one. See, I always confuse these, and if you can help me, I'm very well. You're welcome. No, I'm welcome. I'm thankful. I should have just skipped the slide and not gotten into this. Actually, I will just skip it now. and if you can explain what I wanted to say here, I'll just skip it. Adaptive statistics is something I know a little bit more about. It used to be called Cardinality Feedback. This happens when you execute a query, and during the execution, you discover that what you just did was not really great. So you think you should have done an index scan because you were estimating you only fetched 10 rows, and when in fact you fetched 10 million rows. And this is something that, well, you still went through this once, but you would want further execution or future execution to not make the same mistake. So you're feeding back this information back to the optimizer, back to the shared pool. So you can get the actual results back to the optimizer. You mark this cursor for reparsing, so the next time it gets executed, it gets reparsed with the new statistics. In 11G, this was only being stored in the shared pool. So if you did this once, so you made a bad decision once, you gave feedback back, you stored it in the shared pool. Future queries were aware of this and avoided the situation you got into. But then once you restarted your instance, it was all gone because it wasn't persisted. In 12C, this is getting persisted. You also saw that it's also not spoiled for joins, and the way to do it is it's called SQL plan directives, which is, again, extra information. This stores cardinality feedback, or the information about how many rows I will get back on a predicate basis. So this doesn't really store column statistics. This stores, if I query these three columns together, like age, gender, and something else, zip code. If I query these three together, I usually get like 2 or 3 rows back. This information will get stored as information that has to do with the predicates, not the columns. Which also means that it can be used by different statements that also use the same predicates. And it's stored in sysocs. Look how well I did that. Let me just skip this. There are any histogram types. I don't even know what they are, but I've sat through 3 or 4 presentations that talked about them. I should have just skipped this whole part.
Hybrid one. So rather than frequency, you have. Sorry.
That's fine.
It's called hybrid.
That's as much as I remember. And I had this Penny an awesome presentation where he talked about beer glasses and histograms, and
because you've only got a finite amount of buckets. Rather than having for a popular value having lots of buckets taken, you have a single bucket, but it stores the value of how many items are in that. So it's a kind of a hybrid of a height balance and a frequency.
That's why they call it hybrid.
Yeah.
The second one I know what it is. This is actually solving a cool problem. So before 12C, when you load a table for the first time, create table as is fast and easy and simple. The problem with create table as is, this is doing direct path writes, or direct path writes, or direct writes. But the problem is, when you do this, you don't gather stats with it. And so the first thing you want to do before actually using a table that you just created would be to gather stats. Gathering stats means fetching the blocks that you just went through all the effort to not put them in the buffer cache, fetching them in the buffer cache, and then analyzing them. Cool thing is, 12C now does this for you. So when you populate a table for the first time, either you populate an empty table with insert append, or you create a table as, it'll gather the stats online while doing this, so you don't have to run the gather stats after you went through all the trouble of not putting stuff in the buffer cache. Global temporary tables now get their own private stats. It's being running, can run stats gathering in parallel, and again, and I don't know what this is. I really need to work on my optimizer stuff. But recovery, this is stuff I know a bit more. So single table recovery is a new feature in 12C. Again, this is nothing magic happening. It's just something that there's stuff happening under the covers. You can recover a single table. What it actually will do is it will automate creating an auxiliary database. It'll recover whatever it needs from the auxiliary data in the auxiliary database, and then just copy the content of the table over to your production thing. It's just a convenient syntax. Data guard fast-sync is another feature that solves a problem that does exist. When you do data guard, you can choose between doing synchronous replication and asynchronous replication. Synchronous means whenever you commit in your production database or in your database, you have to wait until that commit has actually reached all your databases. Whereas asynchronous means I'll just commit and then I'll asynchronously ship redo information to another database. Synchronous is really only practical in a very short distance, because if you introduce latency, then that's going to hurt you in your production system. And in 11G, you can only choose between one and the other. 12C lets you do cascading data guard replication. So what you can do is you set up a local proxy, if you will, where you do synchronous replication to, and then from there you do asynchronous replication to an offsite. So you would have a synchronous replication database in the same data center or very, very close by, so very little latency, so not much penalty for doing synchronous replication. And then you have your real offsite database in a different country or different continent or wherever, and you do asynchronous to that.
Is the cascading more general than that? So could you, for example, have a logical standby with a physical standby?
It's not a full database though. It only handles redo. It doesn't have data files.
Yeah. Rack and GI has a few new features, and these I feel quite confident talking about. Flex ASM, I think, is one of the more misunderstood features. When people hear Flex ASM, they think they don't need to put HBAs in all the database systems and can save money. At least I've had a few people think that, and that's not true. So the one cool thing is, the problem it solves is ASM is not a single point of failure anymore. The problem that you have with ASM is if you do database consolidation, you can only have one ASM instance on a box or on a system, but that can serve many, many databases. But it means if the ASM instance crashes, then all the database instances on that system crash as well. And that is a problem, obviously. Or if you want to patch ASM, you have to first shut down all the instances on that same node. And this is where Flex ASM helps. Flex ASM allows you to keep database instances running on a rack node, even though there is no ASM instance running locally on that node. But you still need to have the data path or the access path from the database to your shared disks. You can't get around that. So and if you think about it, this is how ASM actually works. ASM is not sitting in the I/O path. ASM is not doing the I/O for you. ASM is merely just keeping the information of which extent has which data file on it. To this map, it's called the extent map. And then all the I/O is being done by the database. So what Flex ASM allows you to do is if an ASM instance crashes, the database instance will receive this extent map from a different ASM instance, but it will still have to do the I/O locally. Does that make sense? The one important thing is it does not work by shipping data blocks through ASM or through the interconnect. That's not how it works. Even though there were hints at a feature like this in the future, but that would be weird. I'm not talking about Flex Cluster. Flex Cluster is apparently becoming bigger and bigger in 12.2, because I talked to Ian Cookson last week, and I think he mentioned that they are going to force you to use Flex Cluster in 12.2. Basically what Flex Cluster allows you to do is to run a node in your rack cluster without a database instance on it. The idea here is to have a node that you can use to start up stuff that's being managed by the Oracle clusterware, but it's not a database instance. So you could start and stop an application server if you want to manage that with the clusterware. And a node that is not having a database instance does not need to have access to shared disks. So that will be, it's called a leaf node, and opposed to a hub node. A hub node is a node that's a traditional database node that has access to data, whereas a leaf node is a node that does not have access to shared disks, cannot run a database instance, or at least not a rack instance, but you can use it to manage clusterware on it. And I haven't seen anybody actually do anything useful with it, but Oracle's talking a lot about this. Transaction guard is a tiny but rather useful feature. The problem is if you have a system and if your database crashes, right after you issue a commit, you won't know if the commit has actually come through or not. So imagine your application did something, said commit, and it never received an answer to the commit message. That could mean the database never received the commit message and crashed before it reached the database, in which case your transaction will not have committed and will be rolled back. Or the database could have actually received the commit message, put the stuff in the reader docs, and actually recorded the commit in the reader docs, but then crashed before it was able to send the network message back, yes, we did the commit. In which case your transaction would have committed, but you still won't know. Transaction guard allows you to, or it stores the commit number in the reader logs, and it just allows a client or a driver to ask if a certain transaction has committed or not. And if it asks this question, the database will look on the reader stream and answer the question, yes, this has been committed or not. This will help you to avoid committing something twice. And it's the first part of a bigger feature called application continuity. Where the first part is transaction guard, and the second part is the new JDBC thin driver. It's now called the replay driver, because it's always important to rename everything in every new version. So the replay driver is a new JDBC thin, and whenever, well, actually this driver can record a SQL statement and the hash of the result, and it can do that for all the SQL it does. And then when a database instance crashes while there's a transaction in progress, the first thing that this replay driver can do is it can ask transaction guard, hey, I just sent a commit. Has this actually been committed or not? If it has, that's cool. We can just continue with the application. If it hasn't, let me just replay all the SQL that I just recorded. Let me validate that the hash that I get from these inserts, updates, and deletes is the same that I recorded, and then commit the stuff. This doesn't just work for RAC, it also works with single instance where you do Oracle restart. It can also work with data guard, as long as you set the timeout high enough. It does require something called a transaction boundary, which basically is just telling the driver how long it should record SQL for. If you're using WebLogic or the Universal Connection Pool, these transaction boundaries are being inserted by default for you. You don't have to do anything. If you write your own Java applications, you have to insert these things into your code. The one thing you have to think about is what do you do with mutable calls. Mutable calls are calls that include stuff like sysstate or sequences. Because if I insert something that is like insert something sysstate, then obviously if I re-execute the statement 5 minutes later, the hash will not be the same anymore. And you have to decide if you want to just ignore that or throw an error. That's application continuity in a nutshell. This other feature that I don't know much about is called global data services. And as far as I understand, this is helpful if you're doing replication between different sites. You set up one service, and the service knows about all these different replication sites, and you don't actually have to switch stuff in your TNS names for switching to a different site. Tim, is that correct? Yay! And it doesn't just work with data guard, it also works with third-party replication providers if you use those. ASM disk scrubbing is a feature I wish I had in one of the databases of my clients. Probably if you do ASM mirroring, as opposed to ASM external redundancy, then ASM will store all your data extents, all your allocation units twice or 3 times, but it will always only read the so-called primary extent. So every allocation unit will be written to 2 disks, but I always only read from what's called the primary disk. And each allocation unit could have its primary allocation unit on a different disk. That's not a problem. The problem is we can get this thing called silent mirror corruption. We could get into a situation where stuff from the secondary extents or secondary allocation units gets corrupted, and we have no way of checking this. And we had this one client, it's actually Greenpeace, you probably know them. Greenpeace? Is that thing in the UK? So their database, and I always call it Save the Whales. Greenpeace always Save the Whales project for us. So they had some disk issues. It's not funny, Tim. So we took backups, and backups showed us that some blocks were being corrupt. So the messages we saw was primary allocation unit is corrupt. I'm reading from the secondary, and yay, I'm lucky. I'm reading stuff fine. And we saw like 500 or 1,000 corrupt blocks, and there was something wrong with at least one of the disks. And it wasn't a problem to fix the primary allocation units because these were being fixed automatically. That's what ASM does. The problem we had wasn't this was 10G. So we had about 1,000 corrupt blocks on primary extents. I'm sure we had about 1,000 corrupt blocks on secondary extents. So we had about 1,000 blocks that were not being mirrored, right? And because it was 10G, we had no way to check this because when we ran backups and we read anything, we only ever read from the primary extents. In 11G, you could implement a workaround called preferred mirror reads. In 11G, you can, this is basically for extended REC clusters, where you have REC clusters across spanning locations. And you could tell a REC node to please always read from the local failure group as opposed to the remote failure group. This could be used to force this to not read from the primary extent or primary allocation unit, but really not very elegant. 12C has this feature called ASM disk scrubbing, which does exactly what I wanted to do. No, Tim, it's not your block.
I've never even heard of it.
Oh, that's cool. There will be a block tomorrow, I bet. Because this is really cool. You can set this. You can just scrub your disk, and it means please read everything from the primary extent and the mirror extents. Compare these, fix it if there's a problem. And this will take care of that for you. It's a very rare problem, but if you run a problem like this in 10G, you're screwed. If you run a problem like this in 11G, you may get around this with preferred mirror reads, but it's still a big pain to fix. And what we had to do to save the whales was actually basically just set the database up again. We threw the old database away, installed a backup of the old database, and then we knew that all the blocks were right.
That seems an odd choice of words, scrub. In general English, that means wipe it.
Probably means the RAID technology,
Yeah. It may be weird choice words, but it is a common term in anything that has to do with mirroring. So for RAID arrays, there's a scrub option. ZFS has a scrub option, and it always does exactly that. Read both mirror pairs or all parity pairs in RAID 5, and compare them.
I've always heard in the context of scrub the disk.
Scrub it, yeah.
Wipe it.
True.
Air scrubbers, don't you, if it's clean? Air scrubbers, don't you, like for in soap and stuff that clean, so clean rather than.
The time is looking good. So the two Rockstar new features are, and I talk a little bit about Pluggable and not so much about the memory, or at least the slides don't have as much about the memory because I was lazy and didn't that much. So when Larry first announced Oracle 12c, he was still CEO, and this multi-tenant database thing was the big thing that he announced 12c as. And I have to say the adoption rate is rather low. I mean, everybody I talk to is say they have looked at it, they don't really like it, and at most they are using single PDB in a container database, but I don't know anybody who's actually really using multiple pluggable databases in 12c. Anyway, the idea is to use consolidation, manage many as one, have one database, if you will, but plug in many little pluggable databases. The one thing it really has enabled, I think this is a discussion that I'm getting a lot, is this whole database as a service or database cloning. And there are many different ways to achieve this. CloneDB would be one of them. This is, by the way, what I wanted to say when I was talking about Fritz earlier. Flashback. You remember me talking about direct path reads? And Fritz diagnosing this stuff and saying how hard it can be to tell how good or bad your I/O is. If you're using direct NFS, there's really no way at all to tell what your I/O is doing, because you can't even use Linux tools to look at your I/O, because if you do an I/O stat, it's not reporting any of your direct NFS, because direct NFS is being done from Oracle directly to the storage, so it bypasses all the stuff in the kernel. So I/O stat and all the other nice tools you get in Linux won't be helpful. Flash forward, multi-tenant. Database as a service. CloneDB is one of Tim's favorite features. I heard him talk about this 2 times, so to me it's his favorite feature. It's another way to achieve this, cloning databases cheaply. For another client of mine, we did a thing where we set up Solaris zones, and each zone had a database installation in it, and we just cloned these zones, and they were residing on ZFS, so we could just clone them very easily. Delphix has a product that's doing nothing but exactly this. So I think 12c has definitely opened up the discussion, and shops are actually looking at this now. Shops are expecting to be able to clone def and test databases quickly, but not necessarily with 12c multi-tenant. That's that. Different terms. CDB means container database. PDB means pluggable database. And the one good old thing that we all know is now called non-CDB. That is a database that is just the way we all know and love them. That's again the architecture picture. That's another weird picture. This is supposed to show how the dictionary views are sort of working. So one of the things how pluggable or multi-tenant saves resources is by not duplicating all the dictionary objects. So some dictionary objects can be there just once, and then pluggable databases have something like symlinks to certain dictionary objects. So you don't need to have the same dictionary objects in all pluggable databases, and this, in theory, can make upgrades faster, because you don't have to upgrade all the stuff that's really pure SQL or dictionary, because you only have to link to these things. I think in the reality it doesn't really work that well. The other thing is, each of these pluggable databases have their own set of certain tablespace, so systems, sysalgs, users, and temp files. These are all private to each pluggable database, but all your databases, all your plugbases share one undo tablespace. So undo is still something that's being managed at the container level, not within the pluggable databases, which is also one of the reasons why, for example, flashback data archives doesn't work in pluggable yet. You only have one redo buffer and only one redo and one log writer and one redo stream, which also means that if your instances are, if that's a problem for you, if writing redo is a problem for you, then going multi-tenant is not going to help you, because you don't get more of that resource. Yes, container ID. I really don't want to talk about this. There's something called a PDB seed. You use this at the ID 2, and you use this to clone more PDBs. So if you just create an empty PDB, you don't really create an empty PDB. You just clone from the seed PDB. Today, if you want to clone a PDB, it has to be offline or stopped. So you can't clone a live PDB today, which I guess that would be a cool feature.
I think apparently works as well 102 that isn't documented.
I've heard so too, but I haven't seen it yet. Talking about the duplication of system objects. So some system objects, you only have them once, but you have links to, or metadata links, they call it, to these things. There's a concept of common users. So certain users like sys and system are common users. They are basically the same users in all your databases and all your, both the CDB and the PDBs. You can create new users as common users, but you have to give them a prefix. So you can't just create a new super admin user and have it the same in all the databases. You can create local users in all the PDBs, but they could be actually different users. So if I create a Bjoern account in one PDB, it doesn't have to be the same as the Bjoern account in another PDB. There's one listener per CDB. So your container database or your database instance has one listener, and each PDB gets a new service. So if you haven't looked at services yet, this is a point in time where you have to look at services. Because that's also the way how you would connect to a PDB. The way you connect to a PDB is you use the service name that comes with the PDB, use a SQLnet connection, and then connect to it. You can also use, you can't really use the Oracle SID, but you could use toTask, which is a different parameter. And you could set the PDB name in the toTask environment variable, do SQL plus, and then you would be connected to the PDB. Does that make sense? I really don't like talking about multi-tenant. You can't really migrate a non-container database, so a traditional database, into a container database, but you can migrate a non-CDB, so a traditional database, into a pluggable database. So that could be an upgrade path, I guess. Yeah, you can you close a database. Whenever you want to unplug a database, you create a small XML file that has some description about this pluggable database, and you can plug and unplug this in a different container database. You can run the deduplication of the catalog data. So if you upgrade a database from a non-CDB to a pluggable database, you start with a database that has a full catalog. You can then unplug it and plug it into a container database. And then to get some of the benefits of Multitenant, you can run some deduplication on the catalog. Backup really only works from the CDB level. You can restore single pluggable databases. This is basically just a table space restore. But you have to run your backups from the CDB. Oracle says pluggable is awesome because, well, Tim says it's awesome because apparently it'll be the thing, and no one else will be allowed to run non-CDBs, and I hope that's not the case. I hope.
Allegedly, 12.2 pre-12c styling is well exist.
That's
the rumor.
Yeah, I refuse to hear that. I refuse to listen to that. I will start doing something else. I'll start doing gardening or something when that happens.
MySQL is the future.
Oh, MySQL, yeah. Or NoSQL. But the idea is to save resources through consolidation. To get this simple and fast copy and write cloning of databases that you can also get with different mechanisms. To manage many as one, so you only have to patch stuff once. You don't have to monitor one instance or less instances. You back up one large database or one large CDB with all the pluggable database instances in it, instead of backing up multiple smaller databases. Updates you only have to run them once. One of the things that Oracle likes to show is a system where they have two container databases running at different release levels or different versions. So you have an old CDB and a new CDB. And then what they promise you, that what should be able to do is you can unplug a database from here, plug it into here, and this database has already been patched, and that's a faster patching than patching database one by one. But I don't believe that yet.
It depends on the nature of the patch. If the patch changes the catalogue significantly, then you have to run the catalogue update. So you end up taking not as long as, say, 10 patches, but it's significantly longer than just an unplug and plug. So you have to prep before you unplug. You have to run a PostScript after, and that PostScript can take a long time. So it's not as good as it originally sounded, but it still is potentially there.
That's a much better explanation of my I just don't like it.
It's version 1.1 at the moment. That's the reality of it. It's not
True.
finished article.
True. That's what I mean with does at the same time work. If you only use one pluggable database, you can do that. You don't have to buy an extra license. If you use more than one pluggable database, you have to buy the multi-tenant option, which isn't cheap. The bottleneck still stay the same. So you only have one redo buffer, one log writer. So if redo and log writer is a problem for you, then consolidating many databases into one container database is not helping. Everything has to do with ledgers and mutexes. If you have issues with that, you don't get more ledgers and mutexes just because you have container databases. Your container database is basically another single point of failure. If you mismanage anything in there, it'll break stuff. Consolidation always means, and that's one of the challenges of consolidation, is what do you do with the resources? How do you actually make sure that one misbehaving pluggable database does not take down the rest of the pluggable databases? This used to be a German presentation. Some of them are noch nicht supported. Like Flash with data archives. Whatever continuous query notification is, I just pulled this from the documentation. And the heat maps feature, the in ILM, I think this is supported in 12.102 now.
In ILM? I think that's still not. Oh, maybe.
Or not.
I don't think ILM's in it, but it could be wrong.
So they better fix these before they release 12.2. Or just drop them altogether.
Very deprecating.
Yeah, sorry. Can't be bothered. Some people inside Oracle tell you that this is going to be the new standard. 12.2 will require you to use pluggable databases. My counter argument always is Oracle's own products like eBusiness Suite don't even use services yet. So and they always use these hints that have rule-based optimizer stuff in them. So my counter argument is if they don't support this, then we'll be stuck with leaving this. But then again, they come back with saying eBusiness Suite is making progress, and they actually are working very, very much on this. So I'm suggesting this is not going to go away. Tim's saying it is. 12.2 was going to be released in 2016, and I guess we know by then. Real multi-tenant, the one where you actually run multiple databases in one CDB, that may not be for everyone. That may not be the model that people run. I think what we will see if this is if this does take off is just having one pluggable databases inside a container database, the free option, if you will. But in that case, I see the overhead being more expensive than the benefit. So yes, I'm right, or said I'm done with time. Awesome. There's online tutorials not on Tim's side, but on this Oracle side, which is actually quite good. Oracle actually did a good job of getting good labs on there. And do we have time to talk about in memory or not? It's only one slide too. Because I put the slide together before they released it, but actually most of the stuff is really right. On disk, you only store one copy. So on disk, we always have this row format that Oracle now calls the disk optimized format of storing things. But in addition to what you store on disk in the block format that we all know and love, Oracle is now building a column store in memory that's always synchronous to what you have on disk. And it also works with versions. So read consistency also works for the column store. This column store, since it's never being persisted to disk, it has to be rebuilt when you start the instance. And the way it does this is you can specify for each column or for each table that you specify to be in memory, you can specify a certain order that you want this to be populated in, and when the instance starts, it will slowly read the tables in the order that you specify until they are in the column store. And if an object is not in the column store simply won't be used. It's also one of the annoying things if you start using in memory is if you just set a table to use in memory, it'll not be in memory immediately, right? So if you alter table set memory to true, alter table in memory, and then you do a query, it'll probably not use the memory column store because it only gets populated after you restart the instance or after you full scan that object. Cool thing is, there's not much you have to do from an application point. So this is purely something that the DBA can do. A DBA can put an object into the column store by saying alter table in memory and setting a size for the in-memory region. And the optimizer knows about the column store. It knows about which objects are in there and if they are in there. And to the optimizer, this is just another access path. The optimizer now has the option to perform a full scan traditionally or perform a full scan in the memory region. And you can also do this in parts. So if only half of your table is in there, it can also just scan half the table from there and get half the information from somewhere else. And in that case, it's very much like using indexes. The cool thing is, this happens transparently to the application. So there's no real need to rewrite your code. And I think this feature is really awesome because it's so easy to use. The benefit is very easy to prove with a very simple proof of concept. And then all you have to do is decide, do I want to pay Oracle extra money for the speed up or not? But it's a very honest feature in a way, right? Because setting up a POC takes have a box with some memory, alter your biggest tables in memory or just put them all in memory if you can afford to, run your application and see if it performs any faster. If it does perform faster, you can go back to management and say, hey, this runs twice as fast with this option. It costs us this much money. Do you think it's worth it? I think it's very honest and very easy to prove as a feature. With this, it's again, thank you. I made it through the optimizer part that I really struggle with. I hope you didn't mind too much. If we have time, I'm happy to take questions. I'm happy to learn. If not, I want to say thank you again for being here.